Okay, I went and got some tea so that I'm ready to go. We're looking at 5.1, which is the area between two curves. And so here we go, paper view. And we'll get on 5.1. So the idea here, when you're trying to find the area between two curves, you have one curve that's on top, and they say that that curve F is greater than G. G is on bottom, it's lower than F. And if you're trying to find the area that's trapped between them from A to B, then what you have to do is just integrate from A to B, the top curve minus the bottom curve dx. And so one thing I want to say right here is that when you're integrating something dx, then what that means is that any equations that you have, any equations need to be solved for y. Now, if the equation doesn't have y in it, then you wouldn't have to solve it for y. But if it has y in it, it needs to be solved for y. So we essentially have in this problem right here, they've shaded the area for us, problem 2 out of your textbook. We have y equals the square root of x. That's one equation. Y equals 1 over x squared. It doesn't look like an equal sign there, but it is an equal sign. That's the second equation. And a third equation is x equals 4. And so any equations that have y in them need to be solved for y. And that's true. This one has y in it, and it's solved for y. This equation has y in it, and it's solved for y. This equation doesn't have y in it, so I don't have to worry about it. So if I'm trying to find this area here, then I just have to find the area, remember, is the top curve minus the bottom curve dx. And on our interval A to B, wherever everything starts is A, wherever everything ends is B. And so in our case, our top curve is the square root of x, and minus our bottom curve. Now, a good habit, and I almost wanted to forget it right here, is to put parentheses right there. And that way that, particularly if this is a binomial, you'll remember to distribute. In this case, it's not a binomial, so I sometimes forget to put parentheses there, but this is 1 over x squared is our bottom curve. And then our bounds go from this here to here, and that is x equals 1, right, because 1 for our x value, to here x equals 4. So our bounds go from 1 to 4. And we want our bounds in terms of x because we're taking the integral with respect to x. Now I want to go to find this integral here. I'm going to have here the area equals 1 over 4. This is going to be x to the 1/2 minus, and then I want to write this in the numerator, so that's x to the -2 dx. And then remember the power rule, or I call it the unpower rule. You add 1 to the exponent and you divide by the same darn thing. So when I'm thinking about my exponent is 1/2, and I'm going to add 1 to that exponent, which gives 3/2, and then I'm going to divide by 3/2, which is exactly the same as multiplying by 2/3. And when it's a fraction, I say to myself, okay, I'm going to divide by this fraction, so instead I'm going to multiply. So this is going to become, when I take the integral of this, it's going to be x to the 3/2, and then I'm going to multiply that by 2/3, plus, and then this one here, our exponent is -2. I'm going to add 1 to the exponent, which gives me -1, and then I'm going to divide by the same darn thing, divide by -1, which is fine because that's a whole number. So let's see, this is going to be, I put a plus here, but I meant to have a minus. I'm sorry. I was following this sign right here, minus right there. and didn't follow it very well. And so this is x to the negative 1 divided by negative 1. And we're going to integrate from 1 to 4. Notice I have stopped writing the integral symbol. The reason I stopped writing the integral symbol is because I found the antiderivative. And so now I'm going to evaluate this from 1 to 4. Now I might make it look a little bit nicer. So this is 2/3 x to the 3/2. And then this negative and this negative make a positive. Maybe that's what I was doing. Really it wasn't. And I'm going to write x to the negative 1 as 1 over x. So I think it'll just make me happier from 1 to 4. I don't know if it'll make me happy or not, but I think it will. And so I have that my area is going to be my upper bound minus my lower bound, right? And so this is my up bound, and this is going to be my low bound. So in my up bound, I'm plugging in 4. So this is 2/3 times 4 to the 3/2 plus 1 over 4. And then here we have 2/3 times 1 to the 3/2 plus 1. 1 over 1 is 1. And then I just plan on using my calculator anyway to find what this is and minus what that is, up bound minus low bound. So I'm just grabbing a calculator. I've got the Casio 300 here. And so I'm getting my glasses off so I can see. So this is 2/3. Can you see what I'm putting in my calculator? The light shining a little bit. So this is 4 raised to the 3/2. And then plus 1/4. 1 divided by 4. I'll write it as a fraction. 1 divided by 4. And so that part of it is 67 over 12. And then when I do the minus part over here, that's just 2/3 plus 1/3, because 1 raised to the 3/2 is equal to 1. So that's just 2/3 plus 1, which is 5/3. And then when I do the arithmetic, 67 divided by 12 minus 5 divided by 3 is 47/12. And so there we have done that problem there. And so I hope I'm still recording. Something odd came on my screen. And so was it saying, hey, you're running out of battery? I don't know what it was saying. It was saying, hey, this is not your day. Okay, so here this is problem 6. It asks us to set up the integral to find the area, the shaded area. So they've already shaded the area. They drew the 2 lines and the 1 parabola here, and that trapped some area, and then now they're trying to get us to find that area. So as we go to find that area, what we're gonna do to find that area is we're gonna do top curve minus bottom curve. And so I notice that the top curve is this first line and the bottom curve is the parabola. And that happens for a long ways, right, all the way over to here. And then it suddenly changes, and the top curve is the second line, and the bottom curve is the parabola. So I'm going to have to actually do this with 2 integrals, is what I'm going to have to do. So I'm still doing that main idea, is that the area is equal to the top curve minus the bottom curve, dx. So I still have that idea, but I'm going to have to put 2 integrals together, and one of those integrals is going to find this area here, which I'll put little stars in, right? And so that area there, and then the other is going to find this area here, which I'm putting little triangles in. I hope you can tell the difference. And so, which is this area right here. And then when I add the 2 areas together, I will get the whole area. So that's kind of my idea. And so I could even name this area 1, and this over here, area 2, right? And then just find them separately. That would be just Jim Dandy. And so that would just be just great, is what it would be. Now remember that what we said is that if you're going to set up areas and you're going to do top curve minus bottom curve dx, that all your equations need to be solved for y. And so as I look at the equations that I have, this one has 3 equations. Y equals x squared, and 3y equals 2x plus 16, and y equals minus 2x plus 8. So those are the 3 equations that we have, and one of those is not solved for y. And it's this one right here. It's not solved for y. So what I need to do is I need to divide it by 3 so that it will be solved for y. So when I divide this by 3, divide by 3, divide by 3, divide by 3, this will be y equals 2x over 3 plus 16 thirds. And then I am quite liking the idea of calling one of them area 2 and then saying that the area is equal to area 1 plus area 2, and I've already labeled this one area 1 and that one area 2. So I'm quite liking my idea of that the area that we're looking for is going to be area 1 plus area 2, and I'll find area 1 first. So when I go to find area 1, it's the integral, and I want to remind everyone, top curve minus bottom curve dx, and the top curve is this straight line right here. So this is the top curve, and then the bottom curve is the parabola. So I'm going to get my habit back of using my parentheses and then saying when they're not needed. And so here, maybe I have to have bigger parentheses here to write in here, 2x over 3, that's my top curve, plus 16 thirds, minus, and then my bottom curve is the parabola, which is x squared. Because this is a monomial in here, I didn't really need the parentheses. But if it wasn't a monomial, I definitely would need the parentheses. And my bounds on this are going to go from here, which is x equals negative 2, all the way over here to x equals 1. And I'm going to be drawing all these lines, and these lines represent the finding of the area of infinitely many rectangles. And that will find the area here of area 1 there. So that's kind of the idea. So when I integrate this, I didn't put the bounds on there, but I said what they were. They're negative 2 to 1. So when I integrate this, the 2/3 would hold still. I would add 1 to the exponent, which is already 1. So 1 plus 1 is 2. Divide by the same darn thing, which is 2. Plus 16 thirds x, and then minus, and then this would be add 1 to the exponent, x to the third over 3, and from negative 2 to 1. And the 2's cancel here, and they all have a denominator of 3, but I think I'll just go ahead and live with it. So that area 1 equals the upper bound minus the lower bound. So this will be, the upper bound is 1 squared over 3 plus 16 over 3 times 1 minus, gosh, I'm not very good at fitting in my parentheses today. I'm going to have to not write parentheses before I start writing. 1 to the third over 3. So there's my up bound minus my low bound. Which is negative 2 squared over 3, plus, don't run out of room. I'm telling this little monkey here I got this stuffed animal here with me, and I'm telling it to get out of my way. Negative 2, and then minus, and then negative 2 to the third. Oh man, it didn't fit on the paper. Kind of how my day's been going today. But I'm still happy there's a 3 right there, over 3, and parentheses around the whole thing there. And then I'm going to put this in my calculator and find area 1. and then I'll find area 2 and I'll add them together. So when I go to put this in my calculator, I think I'll just go ahead and put it in just like I see it, even though I know that 1 raised to the second is 1. Because when I go to do the -2, I will just be able to edit. So that's my idea. And so that's the reason that I am going to do that instead of how I might do it otherwise. And minus, and then a fraction, and then parentheses 1 raised to the third. And yes, I know that 1 to the third is 1. And but I'm kind of tired, so it might not be that bad of an idea. So this is 16/3. And then I'm going to go change all those 1s to -2. So here we go. So editing in my calculator, all my 1s to -2, hitting equals, and on that I get -20/3. So that area 1 is equal to 16/3 plus, because it's minus of a minus, so it's subtract of a negative, so it's plus 20 divided by 3, which is 12. So area 1 is equal to 12. So this big area here is equal to 12. Now we're going to go find area 2, which is this area over here. And then we'll add them together. So area 2, and remembering it's top curve minus bottom curve. So the top curve is minus 2x plus 8. It's a line. Minus the bottom curve is, so from here to here, the bottom curve is x squared. And the bounds are going from right here, from 1 to, x is 1 to x is 2. So I just have to integrate that and then do my fundamental theorem of calculus part 2. So that's -2, and you add 1 to the exponent. 1 plus 1 is 2 divided by 2, plus 8x minus x to the third over 3 from 1 to 2. And the 2's cancel here. So when we do our up bound, we're going to get negative of 2 squared plus 8 times 2 minus 2 raised to the third over 3 minus the lower bound, which is negative of 1 squared plus 8 times 1 minus 1 to the third over 3. And I know you're saying, how could it be possible that you would almost run out of room again? You didn't learn your lesson on the other one. And the answer is no, I did not. And see all that space right there, that could have been used for that. Okay, so I'm going to put this in my calculator. So putting in my up bound, I'm having negative of 2 squared plus 8 times 2 minus the fraction 2 cubed over 3. So my upper bound is 28/3 minus, and then my lower bound is replace all those 2's that I just substituted into my formula with 1's. And I usually, but I'm really tired, but when I'm not tired, I have to tell you that I try to do it with my head and my calculator to make sure that they match one another. And so this is area 2, remember, and so this is 28/3 minus 20/3, which is 8/3. And so when we put together, our area equals area 1 plus area 2. Remember, that was our plan, which is going to be 12 plus 8/3. And we can do that in our calculator for our area that we were supposed to be finding, which is 44/3. Okay, so we did a lovely job on that one as well. So that's kind of the story. We had two pieces to do, and I said, okay, I'm gonna do them separately and then put them together, and so that worked out really good. So this problem is also giving us the drawing and asking us to find the shaded area, and then set up the integral to find the shaded area, and then after we're done solving it, then solve it. So we have this curve here, which goes up and goes down, and that curve is a cubic. It had two turns in it, so I know that it's not quadratic, but instead cubic. Here was one of the turns here, and the other turn was here. And so y equals 2x to the third minus x to the second plus 5 minus 5x. And then I have a parabola. And it has trapped two different areas. It's trapped this area over here, and it's trapped this area over here. And so I'm going to call them area 1 and area 2, because I notice that, remember that when you're finding the area, that it's the integral of your top curve minus your bottom curve. Oh, I wanted that after that. No, did I just miss it? No, I put this in the wrong spot. Oh, I'll live with it and be happy. Rejoice. But I noticed that my top curve here is my cubic, and my bottom curve here is my quadratic, is my parabola. And then here, the top curve is my parabola, and the bottom curve is my cubic. So that's the reason that I have to do two different integrals, is because the top curve changes and goes below the other curve. So I'm going to find area 1 first. So that's my integral. Remember, I'm doing top curve, and my top curve is this cubic, which is 2x to the third minus x to the second minus 5x, minus my bottom curve. And my bottom curve here is my parabola, which is negative x squared, because it's upside down parabola, plus 3x dx. And I'll get my bounds on there as well. And I'm going to do that same thing. My area is going to equal area 1 plus area 2. So I'll just make my plan known to everyone. And now I'm going and finding, here's area 1, and then I'll go and find area 2. And so my bounds go from x is negative 2. That's where you're going to start integrating here, and all these different places, these different rectangles you would have if you're kind of remembering your Riemann sums, all the way to 0. So this is going to go from negative 2 to 0. If they ask me to set it up, then me saying that area equals A1 plus A2, and labeling this one A1 and labeling this one A2, and then going down here, I'll give myself some room, hopefully enough room, and putting right here that area 2 equals the integral top curve, which is the parabola, negative x squared plus 3x, minus the bottom curve, which is 2x to the third minus x to the second minus 5x dx. And the bounds on this are going from 0, x is 0, to x is 2 here. To x is 2, 0 to 2. If you were just asked to set it up to find the integral, you saying that the total area equals A1 plus A2, and this is A1, and this is A2, that would be set up. And now I'm going to solve it. I'm not going to just take the integral of these pieces. I'm going to distribute the negative. I'm going to combine any like terms that I might have, and then I'll take the integral. So this will be equal, and my bounds are from -2. I wanted to write 0 down there for some reason. I don't know why, to 0. And so this will be 2x to the third minus x to the second minus 5x. When I distribute the negative there, a negative times a negative is a positive x squared minus 3x dx. Then I'm going to combine like terms, and I'm pretty lucky because x squared plus minus x squared plus x squared is 0, so that's gone. And minus 5x and minus 3x is minus 8x. So this will be the integral from -2 to 0 of 2x to the third minus 8x dx. So when I integrate that, when I find the antiderivative of that, I'm going to get 2x to the fourth, adding 1 over 4, minus 8x to the second over 2 from -2 to 0. So my upper bound is 0. When I plug in 0, I just get 0. And my lower bound is -2. So I'm going to get right here 0 minus, and then when I put in 2 over 4, I'm going to use my calculator anyway. So I'm going to put 2 and then -2 to the fourth over 4. I could reduce it. I could 8 over 2 is 4. I could reduce that if I liked. Yeah, I should reduce. Don't be a silly. And definitely I would reduce as my final answer. And so that I had the thought of not reducing along the way was even repulsive. But as my final answer, I would never not reduce. You always reduce. Okay. So I had to reduce. 2 over 4 is 1/2, right? So 2 in the denominator. So we're going to have here, I'm just putting inside the parentheses, and then I'll do the negative of that. So I'm going to have a fraction, and then -2 raised to the fourth over 2. And then minus 4 times -2 raised to the second. So I'm getting -8, and then it's negative of -8. So negative of -8, which is positive 8. So that's what area 1 is equal to. And I said, I hope that I didn't get in the way of this, and I would say that it was darn close. And now I'm having a separator. Okay, so now I'm going to do this one. I have to distribute the negative, combine like terms. So I'm going to do the same on it. It's kind of tedious. It's not particularly difficult. There is lots of chances to make little mistakes on my algebra, and particularly if I get talking and not concentrating on distributing my negative there. Then I'm combining like terms, and so it is true that the x squares cancel out again, and this time the we get -2x to the third, and we get 8x. I need my integral sign there because I have not taken the antiderivative yet, and I almost forgot to write it, so I had to squeeze it in there. And it's not, I mean, I'm not surprised that if your top curve and your bottom curve change places, and when you were subtracting them, that you would have exactly the opposite of what you had here. And so that's not surprising. And so, but I guess that I did it twice gives me a little bit of confirmation. And so -2x to the fourth over 4 plus 8x to the second over 2. And the bounds are from 0 to 2. So when you do the upper bound minus the lower bound is 0, thank goodness. And we're getting here -2, and we're going to have 2 and the 4 cancel and make the 2, remember, and this is going to be 2 to the fourth plus the 8 and the 2 cancel and give us 4, and this is 2 to the second. And why do I cannot make a good decision on size of parentheses tonight? And so anyway, and so I'm going to have in here, let's see, that is negative of putting this in my calculator, and I'm just putting it in just like I see it. And I a lot of times try to do the math in my head, but when I'm tired, it doesn't work out so well anyway, and I am very, very tired. It's very late. And so we hit equals, we get 8 there. So this is A2, and it's a coincidence that they are both 8. But I did remember that they were the same because I've done this problem before. They don't look like the same area, and it's just a coincidence that they're both equal to 8. And so then when we put this together, our final area, A1 plus A2, remember, is our total area, which is 8 plus 8, which is 16. So we did a lovely job on that. And so that's kind of our whole story, our whole problem there. And so we're going to try the next one. So here they've asked me to sketch the region. This problem came out of your book. And so different numbers. So it was a square root of, I can't remember what it was in the book, but it might have been 3x plus 9, whatever it was. And then a line undercutting it. And then y equals 0, which is a horizontal line right here. So everything's been sketched here. And what we're trying to find, what they're asking us to find, is the area that's trapped by these 3 curves. So they've given us these 3 curves. 2 of them were lines. And they're trying to get us to find that area. And there's literally several ways of doing it. And you could do it easily with 2 integrals, because you could say this is your top curve, which is your square root, minus your bottom curve, which is y equals 0. And then over here, your top curve is still the square root, minus your bottom curve, which is the line y equals x minus 2. And so that would be a way of setting it up, and you would have to do 2 integrals. But there's a way of doing it using only 1 integral, and if it's possible to only do 1 integral, I like to only do 1 integral. So I'm gonna get, I meant to have a pencil because I don't like to write on my math notes with pen, but I don't have another pencil, and well, maybe I don't know if I can do it, but if I can write on here. But right here, this area right here, which I don't want to find, but these 2 areas together are easy to find, because it's just the top curve is the x. The top curve is the square root, which is the half a parabola, and the bottom curve is the x-axis. And over here, the same, the square root to the x-axis. So I can find that area very simply. And then the area that I don't want is just a triangle. And so I don't have to use calculus. I don't have to use an integral to find the area of a triangle. The area of a triangle is 1/2 base times height. So that's kind of the way that I would do it to only find 1 integral, is I would use calculus to find this whole thing here. Use calculus to find this whole thing right here. That, and then use geometry to subtract out the triangle. So this is my plan, is to find this, and just so that people know, this is from -2 all the way over here 5, 6 to 6, and then subtract out the triangle. that's in there. That's my idea. So that's my plan in pictures. So to find this area here, that would be, remember that we've been using, the integral is top curve minus bottom curve. Curve not spelled right. Dx. And our top curve is going to be the square root, and our bottom curve is going to be y equals 0. So this is going to be when I go to, and I'm going to call this A1, and I'll call this A2. This time I'm going to be subtracting out A2. So here I am finding A1. So that's the integral from -2 to 6 of the square root of 2x plus 4 minus 0 dx. That's the x-axis, y equals 0. So that's top curve minus bottom curve. I didn't have to write the minus 0, but I just wanted everyone to know that, hey, it is still just top curve minus bottom curve. And you might be saying, well, that's what we learned in the last chapter, is that you would find the area that's from the x-axis up to your curve, right? If you just integrated that, and that's certainly true. Now, I cannot find the antiderivative of this without doing a u substitution, because it's the square root of a binomial. So what I have to do is, this is my plan for my u sub, is to let u equal 2x plus 4. Then du equals 2 dx, which I like to write du over 2 equals dx. But that's me. You do you. And then the bounds, the lower bound was x equals -2. So that means that u equals 2 times -2 plus 4, which is 0. I'm getting low on the paper, sorry. And the upper bound is x equals 6, which is u equals 2 times 6 plus 4, which that's 12 plus 4 is 16. So I have my whole plan of how I'm gonna take that integral. I'm going to use a u substitution. This is my u, this is my du, this is my new bounds. And so, so my A1 becomes new bounds 0 to 16, and the square root of u, and then dx is equal to du divided by 2. And remember, that's u to the 1/2 is what that is. And so I'm in my thoughts, I'm over here, this is u to the 1/2, so that my exponent, when I add 1 to it, right, that's my idea, right, is going to be 3/2. And then I'm going to divide by the same darn thing. So dividing by 3/2 is the same as timesing by 2/3. So I already have this half here. So 1/2 just stays there still, while I then say, okay, I'm going to add 1 to the exponent, so that's u to the 3/2. I'm going to divide by 3/2, which is the same as timesing by 2/3, from 0 to 16. So the 2's cancel out, and I get 1/3, and then this is 16 to the 3/2. That's the up bound minus the low bound, 0 to the 3/2. And I went ahead and just kind of factored the 1/3 out. So I'm getting 16 to the 2/3, the 3/2, 16 to the 3/2. And I can do that on my calculator, but I know that that's the square root of 16, which is 4, raised to the 3rd, which is 64. So I can certainly do that on my calculator. 16 raised to the 3/2, and then times 1/3, which is 64 over 3. So area 1 equals 64 over 3. And remember what our plan was. Our plan, I didn't write it out here, but I have it right here, is to do our area. We'll do that. Equals area 1 minus area 2. And so I just went and did a whole bunch of work to find area 1. And then area 2 is just that triangle, and that triangle has a base of 1, 2, 3, 4. So 4 on the base, and it has a height of 1, 2, 3, 4. So 4 on the height. So the area 2, which is that triangle, is 1/2 base, which is 4, times height, which is 4, which is 8. So that area equals area 1 minus area 2 in this case. So our area equals 64/3 minus 8. So our area equals, and that's just going to be the shaded area. I put in something different than what I meant to put in. And it wasn't, I was looking at it and thinking that can't be the answer. And so I'm getting 40/3. Okay, so we did a lovely job on that. And you do the problem you try the problem another way if you like. Like I say, there's a couple of different ways of doing it. This way takes just one integral. All ways are going to require you to do at least a integral. And I'll tell you that there's a way a little bit easier than this way right here that's still out there. And so give it a whirl. Tell me what you think. I'll tell you, I'll give you a hint when we do something that's similar to what you kind of need to know. Now, on this, they have the graphs. The graphs of two functions are shown with the areas of the regions between the curves indicated. What is the total area between the curves from 0 to 5? And so that's what they're asking in A. They're asking you for the total area. And so this 12 right here is A1, this 27 is A2, and the total area is just A1 plus A2, which is 12 plus 27, which I think might be 39. Okay, and then B says, okay, what if I was to find the integral from 0 to 5 of f of x minus g of x dx? And I told you that the book loves to put parentheses here and here, and I know that there's a lot of teachers that really like those parentheses there as well. But to me, that anything that you have between your integral and your dx, I assume is in parentheses. And so the parentheses, you just get so many of them running around. And so when I'm with someone picky, I put them in. But when I'm around non-picky people, I'm like, oh, okay. And so anyway, and so if we just go back to what they told us about the integral in when they gave us all the properties of integrals, they said that we have the stopping point here at 2. And so that this could be from 0 to 2 of that same integral, f at x minus g at x dx, plus, and then the integral from 2 to 5 of f of x minus g of x dx, right? And then when I'm looking at what these pieces are that I have, so right here I have area 1. And area 1 is equal to 12. And remember that it's top curve minus bottom curve. So this is the integral from 0 to 2, right? That's where area 1 goes from 0 to 2. And the top curve is g. And the bottom curve is f. So that's what area 1 is. And then area 2, I'm going to write that one over here. Area 2, it goes from 2 to 5. The top curve is f, minus the bottom curve is g. Hi, sweetie. Are you okay? Is everything okay? So when I look at this right here, I'm like, oh, this is perfect. That's what I was given. They said that's area 2. And they said that was equal to 27. And when I look at this, I'm like, oh, that's not what was given. That's not area 1. And so, but what I do know is that if I factored out a negative here, because it's just opposite of that right there, right? So if I factored out a negative, this would be negative 0 to 2, and this would then be negative f at x plus g at x dx plus, now remember this was just area 2, which is 27, so I'm going to write 27 there. So I don't have to carry that around and write that anymore. And then if I flip this around, this is g minus f, 0 to 2 of g minus f, which this is equal to 12. And so this would be negative of 12. So now I made this be exactly what I have up there, plus 27. You didn't have to show all of this work, but I wanted to prove to you that if you do bottom curve minus top curve, it's just going to be negative of the area that you expected it to be. And so, and I just wanted to show you that by working it out and doing a little factoring, because, you know, a little factoring is good for our soul. And so 0 to 5 of f of x minus g of x dx is equal to 15. So anyway, so that's kind of the story on number 35 and out of your textbook there. And we're going to try another one here. This one we have to draw. So it says sketch the region enclosed by the given curves. And so I know basically what this looks like. It looks kind of like a flattened out parabola. And but what I'd like to do is I would like to pick a few points on there. And remembering what this is y equals, I'm going to be picking x's, but raised to the 4th, and there are parentheses implied there. So we get, when we're substituting, when we put in 0 here, we get 0. When we put in 1 here, we get 1. When we put in negative 1, right, negative 1 raised to the 4th is also equal to 1. And you can use your calculator. And I put in 2 when I was doing this by myself, but then I realized that's so big that I probably am not going to graph that. But maybe I'll need it. You know, you never know. And then 16 as well if you put in negative 2. So I'm going to draw this over here. And 0, 0 right here. And I'm going to put 1 right here. And I only am drawing this so big is because I have the confidence of having drawn this actually 3 times today. And so since I've drawn this 3 times today, I know that I can kind of draw it big like that. And so here's 0, 0, and here's negative 1, 1, and here is 1, 1. And I'm going to kind of sketch this in here. It almost looks like a parabola the way I've drawn it, but it probably is a little bit more flattened out, but that's not really critical. Now, I know that this thing right here is a V, and when you're wanting to find the vertex of your V, then what you need to do is you need to look at the inside of your absolute value, that inside, and you need to let that equal 0. And in this case, that would be x equals 0. So when I start picking points, that's where I want to start, is with 0. And so then when I put in 0 in here, I get 2. And then I might try 1, and I might try negative 1. When I try 1, I get 1. When I try negative 1, now the absolute value of negative 1 is also equal to 1, so I also get 1. And I'm kind of like, oh, wait, that's looking pretty good because I've got some points here in common. Let me draw those. And then if I need more points, I'll get more points. So over 0 up 2, over negative 1 up 1, and over 1 up 1. And I know that this thing is a V like this. And so the area that got trapped is this area in here. And because absolute value, you can't take the integral of something with absolute value. You have to get rid of the absolute value. And so if you have an absolute value, you need to get rid of it. Now, the good way of getting rid of the absolute value is just to use the definition. And so I know the absolute value of x is either equal to x or negative x. And so that means, hi, Susie. I'm sorry, honey. I'm almost done. So that means that y equals 2 minus x, absolute value of x. Yeah, you're going to say hi to everyone? I don't know what people are going to think about you getting involved in the math, because everyone knows that you really are not a math girl. And so, you're not really good on the calculator either. So the absolute value of x is either equal to x or negative x. And so, and remember, this is if x is greater than or equal to 0, and this is if x is less than 0. So if I replace it with x, then this would be 2 minus x, and this is if x is greater than or equal to 0. And if I replace it with negative x, then this would be 2 minus negative x, which would be 2 plus x, and this is if x is less than 0. So this gives us, so on this side is where x is greater than 0. So this line right here is the line y equals 2 minus x. And then this line over here, this is the side that's smaller than 0. So this is y equals 2 plus x. And then just a quick making sure with my brain and thinking about it to make sure that I have this right. This is saying the slope is -1. And so if I look at this line, yeah, it does indeed have slope -1. This over here has slope 1, and this does indeed go positive slope 1. So I'm like, okay, I think I have this down. And I don't want to have to do, because I'd have to do an integral for this part here. The top curve is that line, y equals 2 plus x, and the bottom curve is the raised to the 4th, x to the 4th, right? Whereas this over here is a different function for the top function, the top curve, and the bottom curve is the same curve. And so I would have to do 2 integrals. But if I notice the symmetry, that this is exactly the same size as this, what I can then do is I can just do one piece of it and double it. And so that's what my plan is going to be, is to integrate to find half of it and then double it to find the whole thing. So that's going to be my plan. And this side over here is my side A1. And I notice that A1, I'll call this side over here if you want A2. And I notice that A1 equals A2. That's what I'm just noticing, right? And so I'm going to go ahead and I'm going to say that the total area equals 2 times the integral. And then I'm just going to find A1. And you could do A2 if you wanted, but I do better with positive numbers. And so because area 1 is in the first quadrant, it's just easier, I think, with the positive numbers. So this is going to go from x is 0 to x is 1. So those are my bounds, 0 to 1. And then the top curve was 2 minus x. And the bottom curve was x to the 4th dx. And so if someone asks you just to set this up, there it is. Boom. Go on to the next one. And now they're asking me to find the integral. And so I'm going to find the integral. So the integral of, I'm going to just hang this 2 out here and try not to lose it. The integral of 2 is 2x minus x squared over 2 minus x to the 5th over 5 from 0 to 1. So doing top curve minus bottom curve, so this is 2 times, and then I'm going to have the top curve, which is 2 minus 1/2 minus 1/5. Nice because it's 1. And then all of them have x, and 0 is boom. And so we are getting 2 minus half minus 1/5, and 13/10 is just area 1. It's just half of it. And then when we multiply by 2, we get the other side as well because they're equal to one another. And so what is that? 13 times 2, is that 26? Over 10. And yeah, of course you should reduce. Everybody, every time. Everybody, reduce with me. Reducing is fun. Reducing is what we do. Our calculator reduces. So there's no reason for us not to. Okay, so I feel like I better make sure that 2 times 13 is 26. It's been one of those days, if you know what I mean. Okay, so we did a lovely job on that one. Oh, yes, and I had done that one earlier and did get 13 over 5, and so that makes me feel really happy. Okay, one more. And then I'm going to do something about how cold I am. My tea is cold. My still tastes good though. Okay, sometimes it's not easy to get the variables solved for y, and sometimes if you have things solved for y, you have to use more than one integral, and in fact we've used more than one integral on a few of them. And so there's another way that you can do it, which is to get your variables instead solve for x, and then do dy. And then when you do that, it's the curve on the right curve minus left curve. So your variables need to be solved for x in terms of y, and variables solved for x in terms of y, and then it's right curve minus left curve, and you can find the area. And then your bounds are going to need to be in terms of y, and so from your lower bound for y to your upper bound for y. So we're going to draw a picture on this one, and we're going to we'll look at it both ways so that you can make a decision. So if I go to graph this, and I gave myself extra room here because I knew that my graph might get big, and so x equals y to the fourth. Well, I essentially already graphed that, but I graphed it. This one's on its side. So if y is 0, x is 0. If y is 1, x is 1. If y is negative 1, then x is 1, because remember there's parentheses there, right? And if y is 2, then x is 16. I don't know if I'm going to graph, if I'm even going to plot that. And then we also have 16. I almost made a negative there. I've been doing that today. It's my story today. And so I'm going to draw here to the best of my ability. Let's see, this one here, I want to pick underneath here. I'm going to pick 2 first, and then negative values. So I have to go over here. I'm just kind of trying to give myself some room. So this is 0, 0, and up 1 and over 1 here. And so over 1, up 1, and then down 1 and over 1. And so here, and if I need the other, and I know that it probably should be a little flatter, but you know, that's how I'm drawing them today. Okay, and so there's that one. Now, when I pick values, I want to find, when you graph a square root, that's half a parabola. And I want to find that vertex part on my parabola. And how you find it is you let the radicand, that's the part underneath, be equal to 0. So in my head, I'm thinking 2 minus x equals 0. And, well, if x has to be 2 then. And so that's what I want to start off by picking. So I'm going to pick 2. And when I do, I'm finding the square root of 0, which is 0. And then the next thing I want to pick is I want to pick x so that I have the square root of 1 is what I'm going to find. And so what I have to pick for x so that I get the square root of 1 is I have to pick x as 1. And then it's the square root of 1, which is 1. Then I'd like to get the square root of 4. And what I need to pick so that I get the square root of 4, so this is what I'm thinking in my head, 2 minus x equals 4, because that's what I want to pick. So if I take away 2, then I get negative x equals 2, and I get x equals negative 2. So I need to pick x is negative 2. You didn't need to solve it if you knew that that was what it was going to be, so that when I take this, when I plug in x, I get the square root of 4, which is 2. Okay, so I'm going to plot these points. So right here is 2, 0. Right here is 1, 1. And here is negative 1, negative 2, up 2, negative 2, up 2. And so I've drawn this in here. And that's not trapping any area right now. What's going to trap some area is when I graph y equals 0. And that's the x-axis. So right here. And so this is the area that is trapped. Okay. So I have one equation solved for x and one equation solved for y. So I get to choice of, do I want to do it dx, which means all my equations need to be solved for y. And I can certainly do that because you just take the fourth root of both sides and you'll have this solved for y. And this is already solved for y. But you're probably noticing that when you have a square root of a binomial, you'll have to do a u substitution when you go to integrate it. And so that's one way. The other thing that's wrong with that is that I would have to do two integrals. Top curve, which is this one is this first one, right? Minus the x-axis, right? Y equals 0. And then the other one is my square root minus the x-axis, which is y equals 0. So I would have to break that into two integrals if I wanted to do it dx. But if I decide to do it on its side instead and do right curve minus left curve, then here's the right curve, which is my square root, minus my left curve, which is my fourth degree thing. Remember, I got to solve all my variables so that they're all solved for x if you're going to do right curve minus left curve. But you notice that always that's on the right and that curve is on the left everywhere. And so I'll only have to do one integral. So that's the reason why this would be good. So I want this one solved for x. It is solved for x. I want to solve this for x. So how I solve that for x is I square both sides. So I get y squared equals 2 minus x. And then I think I will add x to that side and subtract y squared. Would that be okay? So that would be x equals 2 minus y squared. So now I have these two equations that I'm going to be using. I guess this one too, but it's minus 0, right? Okay, so when I do my area, I only need one integral, and this is going to be right curve minus left curve dy. And the curve that is on the right is the one that was the square root, but I solved it to be this. So this is going to be the area equals the integral of 2 minus y squared minus, and then the fourth degree thing, which is x equals y to the fourth. dy. And then the bounds are going to go right here from y is 0, right? And this is where I'm integrating all the way from y is 0 all the way up to y is 1. So from 0 right here to 1 is where I'm integrating. This is all my places where I'm drawing all my little Riemann sum, my ideas of my rectangles that I had from before. So from 0 to 1 is where I'm going to be integrating. And so now I'm ready to this. If someone asks me just to set it up, there it is. It's set up. I'm done. And so, but the second step they asked me to do is integrate. And so this is going to be 2y minus y cubed over 3 minus y to the 5th over 5 from 0 to 1. And so when we put in our upper bound, that's 2 minus 1/3 minus 1/5, and then minus our lower bound, which is 0. So our area is freezing right now at my house. It's freezing because I haven't turned on my heater because I'm lazy, I guess. I don't know why I haven't turned on the heater, but I haven't. Okay, so we did that. So we did a really, really lovely job on that. And so I feel like that when you do right curve minus left curve, that I should write right here, must solve equations for x. Okay. And so I didn't use that room over there that I have. I guess I could have used that room over there to show the other way of setting it up, but that's going to take 2 integrals, and I don't want to do 2 integrals. It's late. We'll just leave it with 1. Okay, very good. That's all. See you tomorrow.